Hi Math 34 students. This is Module 4 and we're going to start with example 1 on page 88. Remember to first read through the vocabulary on page 87. So example 1 is an example from Vitruvius, who connected the proportions of the male figure to the proportions used in classical architecture and wrote that a man's arm span is equal to his height. So you may have heard of this, that if you stretch out the length of a person's arms and compare it to the height, that they are very close. Below is a scatter plot and a best fit line, which we know is called the least squares regression line, or just the regression line, for the arm span and height measurements in centimeters for 11 men. So down here on the x-axis we have the arm span, and on the y-axis we have the height. So part A wants us to go ahead and use the data points in blue to find the observed height, which are the actual heights of these men, for someone who has an arm span of 173 centimeters and then 196 centimeters. So if we come over to find 173 centimeters, we see it's right here. This must be counting by twos, right here between 172 and 174 centimeters, so right up here. Go ahead and circle that arm span. And then we can go ahead and say that looks like it's 185 centimeters. So we'll go ahead and type that in over here. Now for the man who is 196 centimeters tall, we know this is counting by twos, so we count over 192, 194, 196 is right here, and we come up and use this measurement right here. And that, if we come over, looks to be 184 centimeters. So these are what are called the observed heights because they are from the actual data. Now we want to use the graph and use the regression line to predict the height of the man with the same arm span. So if we come over to 173 and look up at the graph, that looks like a prediction of 174 centimeters. And similarly, if we come over to 196, that prediction up here looks to be 191 centimeters. And again, we're estimating from the graph, but it's a pretty clear line, so I think we read it spot on. So obviously, the graph of the least squares regression line does not predict the height of every man accurately. Remember, it's just the regression line of best fit. It's not a perfect prediction. Anytime we're working with real data, the best we can hope for is the best fit, not a perfect fit. So let's consider the man with the arm span of 173 centimeters. Is the predicted height from the graph an overestimate or an underestimate? And if we look back, we see the predicted height was an underestimate. We see the predicted height was 174 centimeters, but the actual observed height was 185 centimeters. So now we want to go ahead and calculate the error, otherwise known as the residual, in the predicted height for a man with the arm span of 173 centimeters. So the error is the observed height, 185, subtract the predicted height, 174 centimeters, and our answer is 11 centimeters for the error. Let's go ahead to the next page and look at our other observation. So now we consider the man with the arm span of 196 centimeters. And was his predicted height an overestimate or an underestimate? Well, his predicted height is an overestimate. And let's go ahead and calculate the error down here in part F. So the error, also known as the residual, is the observed height minus the predicted height. So our observed height was 184 centimeters. Subtract the predicted height of 191 centimeters, and our error here is -7 centimeters. So it's okay to have a negative error. Often in a science class, what you'll do is take the absolute value of the error, and you'll see that sometimes will come up when we do our statistics formula. In this case, we're just calculating the error, so because the height prediction was an overestimate, the actual height was below and we get a negative error. Let's look next at example 2, still on page 89. So the table below gives us the height in feet and then the speed in miles per hour for 20 different roller coasters. And remember, roller coasters rely on gravity, so we suspect that the higher the roller coaster, the faster the speed is, depending on how the drop is set up. The equation of the best fit line, otherwise known as the least squares regression line, is provided right here. So you can type it up as predicted speed, which is our output, or our response variable, equals 40.31 plus 0.18 times the height, which is our explanatory variable. Or you could do it in y equals 40.31 plus 0.18x form. In the OLI software, you'll see they use words instead of x and y, which makes it maybe nicer to follow, but you can always replace the explanatory variable with x and the response variable with y. So now there's a typo in here. I want you to work on the predicted speed in part A, but I accidentally typed observed speed in the top. So let's go ahead and show that these should be flip-flopped. Okay. So for the height of 72, we want to use our prediction equation or our regression equation to calculate out the predicted speed. Okay, so to calculate our predicted speed, we say 40.31 plus 0.18 times 72 for our x value, because that's our height. And if we calculate that out, we get 53.27 miles per hour. Then let's go ahead and do the same thing for a height of 415. So we're going to say 40.31 plus 0.18 times 415. And we get here a predicted speed of 115.01 miles per hour. So now we want to go use the table to look up the actual observed speed. So if we find 72 feet height, that corresponds with 44 miles per hour. So remember, the observed speed is just the actual speed from the table. And 415 feet, if we come down here in the table, corresponds with 100 miles per hour, the observed speed. So let's consider the roller coaster with the height of 72 feet. Is our predicted speed an overestimate or an underestimate? So if we look up top, the predicted speed was 53.27 miles per hour, and the observed speed was 44 miles per hour. So this is an overestimate. And then let's consider the roller coaster with the height of 415 feet. That had predicted speed of 115.01 miles per hour and an observed speed of 100 miles per hour. And so that also is an overestimate for the predicted speed. So now let's go ahead and calculate out the error for the roller coaster that had height 415 feet. Remember, the error is also known as a residual. So in your OLI software, you'll hear reference to the residual, and you'll know that means the error. So we start with the actual or observed speed, subtract the predicted speed, and we get negative 15.01 miles per hour. And again, our error is negative because we have an overestimate. Okay, the next video we'll go into example 3 and 4. Example 3 is a longer example. So take a minute and read through example 3 before you start the next video.